In this video, we will explore how the leading term of a polynomial impacts the end behavior of the polynomial. So for a polynomial, the leading term of the polynomial is the term with the largest exponent. And then the leading coefficient is the coefficient on that leading term, and the degree of the polynomial is the exponent on that leading term. So the leading term is like the term with the largest exponent, and then we can also look at the leading coefficient and the degree to refer to the coefficient and the exponent. So in this example, 3x squared plus 10x plus 90, the term with the largest exponent is 3x squared, and therefore 3x squared is the leading term. So that 3x squared is that leading term. The coefficient on that term is 3, so 3 is the leading coefficient for the polynomial. And then the exponent on this leading term is 2, and therefore 2 is the degree of the polynomial. Recall that when we look at a polynomial expression, the term with the largest exponent becomes increasingly close to the total value of the polynomial expression when x increases or decreases without bound. So when x is really, really large in either the positive or negative direction, that leading term ends up being a very, very good approximation of the total polynomial. So consider the expression 3x squared plus 10x plus 90. As x gets really, really large in either the positive or negative direction, this 3x squared, that leading term, is what the entire polynomial expression essentially looks like. So we can say that as x increases or decreases without bound, we represent that with this. So as x increases or decreasing without bound, then this entire expression, 3x squared plus 10x plus 90, the value of that expression looks essentially like 3x squared, where the value of this polynomial approaches the value of 3x squared. So as x increases or decreases without bound, this polynomial expression essentially looks like 3x squared. Now we know some things about how 3x squared behaves in the long run. So we know that as x increases without bound, x squared is going to increase without bound, and therefore 3x squared should also increase without bound. And we can also say that as x decreases without bound, so as x decreases without bound, 3x squared is again going to increase without bound because the negative number squared is going to be a positive number, and it's going to be increasingly large as x decreases without bound. So we can put these two things together. We decided that as x increases or decreases without bound, 3x squared plus 10x plus 90 behaves like 3x squared. And then we also decided how 3x squared behaves as x increases or decreases without bound. So we can start to say things like, as x increases without bound, 3x squared plus 10x plus 90, the value of that expression approaches the value of 3x squared, and 3x squared increases without bound. And therefore, 3x squared plus 10x plus 90 increases without bound. We can kind of eliminate that middle step right there. We'll just draw an arrow past that. And similarly, we could say that as x decreases without bound, again, this 3x squared plus 10x plus 90 is going to approach 3x squared, and 3x squared is going to, again, increase without bound. So we could say that 3x squared plus 10x plus 90 increases without bound. Okay, let's look at one last quick example. Consider the function f of x equals negative 3x cubed plus 20x minus 15. Our leading term is negative 3x cubed, so as x increases or decreases without bound, so as x goes either to the right or to the left, f of x, or the value of that polynomial expression, approaches that leading term, which is negative 3x cubed. We can also say things about how negative 3x cubed behaves as x increases or decreases without bound. So we could say that as x increases without bound, we could say f of x approaches negative 3x cubed, and as x increases without bound, x cubed increases without bound. And so negative 3x cubed should decrease without bound. So a positive number, a really large positive number cubed is a really large positive number. Multiply that by negative 3, you should get a really negative number. And so f of x decreases without bound as x increases without bound. Similarly, as x decreases without bound, f of x again is going to begin to look like negative 3x cubed, and negative 3x cubed is going to increase without bound. Because we're looking at really large negative numbers, we cube those, we're going to get a really large negative number. We multiply by negative 3, we're going to get a really large positive number. So as x decreases without bound, f of x increases without bound.